What's up, everybody? Welcome to another episode of Archill podcast. Today I'm joined with Shota Gvinepadze, a mastermind behind mathematics and computer science school at Free University of Tbilisi, associated dean for about 8 years now, a lecturer and one of the most enthusiastic educators I've ever met, an outstanding software engineer and technology geek, founder of startup Vitsi.ai, which aims to revolutionize the whole process of learning. Personally, I'm a big fan of education, and therefore I'm super excited to share this episode with you. So without further ado, here it is, my conversation with Shota Gvinepadze. Enjoy. So Shota, can you tell me what was your first programming language?
I started programming in BASIC when I was 5th grade, I think, but it was really short time. And then I switched to Pascal very quickly, and I coded on Pascal quite some time, all my school years, and then I switched to C++ and C, and then like different languages.
Yeah, and does it actually matter, like, which programming language we choose for our first one?
Do not choose BASIC. You'll be damaged. It's a fun joke, but yeah, it actually does not really matter because you don't learn. So it depends what you want, right? If you learn just the programming language, then yeah, you choose whatever programming language you want to learn. But if you want to learn software engineering and to build things and problem solving, solve some problems, then it really doesn't matter. It would be the kind of same thing when you choose a language to write an essay. The language doesn't really matter, right? What matters is the essay itself. So that's that.
Okay, got it. Thank you. So now let's switch to like way more high level than programming languages, and let's talk about these terms like software architecture and software design. Okay, can you tell us what these people do out there? I mean, do they just code? Do they think? Do they write some stuff? Or what do software designers or architects do? And is it even correct to say that architect and designer is kind of same thing?
It depends actually, right? So the main skill in software engineering is problem solving skill, and it depends on the problem and how big or small is your problem. The bigger or smaller your architecture will be. And spending time on an architecture for small problems, it's counterproductive. So the problem should be big enough to think about the architecture, right? And to justify the time spent on that. And if it's big enough, and if you have to think about architecture and how things are built, it then even depends on architecture. What exactly you mean by architecture, right? So if we're talking about some software engineering problems, so we have to build some software. We will have to think definitely that it should be bug-free, reliable, and with that, have to think about that. We'll have to think about probably changes, because if product doesn't change, software doesn't change, it means no one needs the software probably, and that's why it doesn't change. So good software always changes. So we have to think about things like maintainability, and if we like want to have like millions or billions of users, we have to think about scale. So it all depends on the problem we have at hand, and thinking in advance, like building a scalable architecture, blah blah blah, when you do not need it, it's counterproductive. So I learned that hard way. So when I was young, I always thought that like good software in the sense that scalable software, like lots of abstractions and lots of tasks and whatever, is the best way to go forward. But uh, it actually depends on a problem. So for small problems, it's like overkill, and you have to like do whatever it works.
And just a follow-up question here. So if I understood it correctly, is it like this? Like you solve only those problems which are at your hand right now. And what is the moment when we should care about scalability? Obviously, like for example, like even YouTube or Facebook initially had like small amount of users, maybe, right? And should we care about scalability like when we start developing our product at all, or we should never care about it and in the process do that?
Yeah, probably not. Like, so if we are talking about it also depends. If we're talking about startups, uh, and you don't even know if your product is solving the problem for a user, and you are searching for the product market fit, who cares about the scalability,
Yeah.
right? You even if you solve the problem for one person, it's better than have a scalable
Yeah.
product like which can like have like billions of users but doesn't solve really anything.
Yeah.
So yeah, it depends on a problem at hand. Like you mentioned Facebook, like when Facebook began, they their user acquisition, they had like uh campus by campus, for university by university.
Yeah.
So they onboarded, for example, Harvard University students, then like Penn. I don't remember which ones
Yeah. Whatever.
first, but they had dedicated servers for each university. Like the
Yeah. Yeah. I
scaling was
remember.
that, and Harvard University students could see only Harvard University students, and they couldn't even communicate with other students. Like they actually had like 10 different servers for 10 universities, and on each server
Yeah.
there was like PHP instance and MySQL or whatever database they had.
Yeah. Okay. Got it. So basically, like if we know in the beginning that our system will have definitely high load, then we design it for high scalability, right? That's it. Otherwise, we just do it on
Yes,
the fly.
so if you exactly, so if you're working on Facebook right now and you know
Yeah.
you have billions of users, and you know like product you will be building will be for billion, like billions of users will use it, yeah, then you should think about the scalability. But for startups, yeah, it's premature.
Yeah. Okay. That's super clear. And now I want
Even
you
though
to.
it's really
Yeah.
fun, right? It's yeah, sorry.
No,
Yeah, I
go
want
ahead.
to just
Yeah.
add
Go
that
ahead.
even though it's really fun and cool to think about scalable
Yeah.
products,
Yeah.
but yeah, that's rarely the case that startups need that.
Yeah. So we should care about users other than like about architecture first. So
Yeah.
now I want you to kind of walk me through the process of decision making behind the software design, whatever. So let's say a client or a person who kind of asks us to build some product comes to us with some requirements. And can you just walk me through the process, like from getting these requirements, then with communicating with that person, with that party, and then kind of building this final product and moving to production? How is this flow? I mean, what happens in that kind of chain of processes?
Yeah, there are different processes actually how this could be done. But let's go with just one of them.
Yeah, sure.
So, for example, let's call them a product owner,
Yeah,
for lack of a better term, wants to build some product, and they know what they want to build, which is very rare that
yeah,
people know what they want to build. And if they know, that's not a good knowledge as a rule, because when when you collide with the users, like when you give the product to the users, it really changes. But yeah, okay, let's start with that. And they know what they want. And so they have some specifications. So you write down specifications, you talk about them and discuss which is possible, which are not possible. There are always time constraint there, and you have to get rid of some features. So basically what you do is you list the feature list. You have a features, what you want to build, and then you can prioritize like which features are must have, which features are good to have, and which features like maybe like in three priority with like red, yellow, and green. It's as a rule, it's done like this way. And then, but the main thing here is like every product is done for some users, right? And the probably most likely when this product owner comes to you, they already have talked to their users and they kind of know what users want. So they have this iteration with users already gone. They have user interviews done and whatnot, and then they came to you to build, like to build whatever users told them that was a product that solved their problem. And then you start building the product, right? Feature by feature. But in that process, it's better to communicate to the users as soon as possible, bi-weekly or weekly basis, to get feedback from them and to understand like whether whatever you're building is really solving the problem, really solving their problem. So the process should be iterative, and the smaller iterations are the better for the users, for the end users. You can of course like build like this. So someone gave you specifications, you went like for a year, built this product, it took a year, then gave the product to the product owner, and then they start selling this to the users, and it turned out that users wanted, I don't know, different product.
Yeah,
so
something
they
else.
stopped. So the year is gone, and you did basically nothing productive.
So we should ship as fast as possible, right? And get product to users' hands.
Yeah,
Or
the
not.
ship as fast as possible is very good idea, and iterating with the user feedback. So that's the must. Even so, I had lots of so even if this product owner person doesn't understand this process, so you should be the one to force it on them, because the product you are building is your responsibility, and it will be best if whatever you build is really solving the problem for users.
Okay, got it. And as far as I know, you like, and as we can see from your cap, you worked at Mattermost, right? Can you tell us what you
Yeah.
did there, maybe? Because your resume just says you were a software designer or something like that. But what does that actually mean? And what were your kind of primary responsibilities there? Can you tell us?
Yeah, Mattermost is a really cool company.
And what it is
It's an open
actually
source.
also, yeah.
Why?
And no, what it is actually, if you can tell us as well.
Oh, wait, yeah. Yeah, so Mattermost is an open source product company. It's fully remote, and really cool. Really cool people work there. It's a lot of fun. And what it does is it created the Slack alternative, basically on premise. Like you can install your own instance of Mattermost and chat within your organization. And all the data, all the messages, whatever, will be within your system, and no one. So basically, it's kind of secure Slack in that sense. And Mattermost has lots of really cool users. You can see the list list in the website. So Mattermost is a big product. There are lots of features. There's a feature list we want to implement on. We wanted to implement on that. So I do not work for Mattermost.
Yeah.
But yeah, what we wanted to implement some feature list, and the person was responsible for building the feature, for example, me. And then I would write a design document for the feature. I would write whatever help I needed, like in terms of man hours or in terms of data or whatever the
Some resources.
whatever the feature would resources would I need, and then I would manage the feature to the end, communicating with the testers as well. So that was how we worked, and that what the design part is in the engineering designer or whatever. I don't even remember what
kind
the
of
name
leader
was.
of some group who delivers features, right? And is responsible for that delivery.
Yeah, and the cool thing is it was feature by feature. So you could be a leader on one feature, and you could be the follower on a bunch of other features.
Oh, that's amazing.
That was really, that was really cool. So you could grow in that sense. So that was lot of fun.
Yeah, that's actually cool because like lots of kind of high level engineers in terms of seniority lack that coding experience, and that would have been fun, I guess, to be follower in some and actual coder of some features. Now what I want to ask is kind of mostly about these open source products, because I think to me it seems that running a product and a company which has an open source kind of code should be slightly different, because so what I think, everyone can contribute, right? Everyone can see some public tasks, implement them, and how is that process different from like dedicated team products? I mean, is it even different at all? Because like you create some ticket and give it to the public and somebody takes it, or how does it work with this open source part of the product?
Yeah, that's kind of very, very good question. So I really love open source from the get-go. So I love open things. I love when decisions are made openly and you can track how the decisions were made. So I love that, and I would implement this anywhere, like in any system, in any organization that will should that will in any organization that will guide the healthy organization. So it will be cool if, for example, governments had that. If it will be cool if these big organizations had that. So when decisions are made openly and you understand, any user understands why this decision was made. So that's really cool. I understand that there are some decisions that might be problematic to open up for public. It might be some I don't know, some secrets, but they are very, very that's very small amount of the secrets. And the secrets are like, it's also time capped, right? Secrets are like I don't know, like 10 years secret for your organization, maybe. But yeah, so that said, managing an open source project or working on an open source organization is pretty different. So whenever you're designing a feature, when you design so you list out tickets, you list out the tickets for open source community as well, and you manage the community too. And you educate the community who want to implement these tickets on how to do that. There will be lots of questions they might have, like on different topics. Basically, you are guiding them through your product itself, but not only the product. You probably will be guiding them on different software engineering skills or methodologies or paradigms for them to contribute better better code because you will be reviewing their code, right? So that's very good relationship. So uh, you are kind mentor to the community. There are of course community members who are way better than you, and it's other way around,
Yeah, of
and
course.
they guide you and they mentor you.
Mm-mm.
So yeah, there are that cases as well. But as a rule, people who contribute to open source, they contribute to learn things, and you have to be the part of their journey. So and you have to plan for that. So the tickets you are creating for open source should be designed in a way that it should be they should teach something new and that should be fun to work on. So yeah, that's not easy always, but it's a very good skill to have. So when you're designing the feature to create this kind of tickets. Uh, so yeah, that's different. And
Let me
when
ask you.
you're like in the
Uh,
closed source,
yeah.
okay,
Just go ahead. I will ask then. Yeah, just go ahead.
yeah, when you're on the closed source environment, so you don't even care, you don't think about that, right? You just come up with a bunch of tickets, and then you even do not write the tickets properly, whatever that should be, and then someone picks it up, and then you talk it over, maybe like, oh,
Yeah.
I meant that in this ticket, or that. So in the open source, the communication skills should be like top. I think so. You have to communicate very clearly what you want from the ticket, and that's very very important. So yeah.
Okay, now let me get to why part of that. So why? What is a benefit? Obviously, like to contributors, it's a great opportunity to learn new things, right, and contribute to some huge projects. But what is the benefit for the company? I mean, what do they get? Because they spend a lot of time, I would say, write those special tickets and communicating. But what's the benefit in this process? Or is it just some philosophy that people follow?
Both probably. So it is a philosophy. Then everything should be open, and so you can do whatever. Like you can then rebuild on top of open things. But um, uh, I don't think that it's that much time, like extra time.
Okay.
I think so. Open source community, they contribute, right? So they give you value, the actual value,
Yeah.
uh, and they are kind of extension of yourself. For example, if you had like similar tickets, like you um like what would be a good example? Like you like for example, you switched from JavaScript
Yeah.
to TypeScript. Like that's like very like um simple example. And now you want your code to be on TypeScript. Like you did it on several files, and then you like open source it and guide others to do on like you
Okay.
did like 5%, maybe 10% of the
Yeah.
code base, and like 90% is done by the open source community. So this is really huge help, or like tasks uh, as a rule are done by open source community. The translations are done by open source community as a rule. And so there was lots of help from open source. That's one thing. The second thing, yeah, we mentioned the philosophy, like of it to be like default open, like everything's open. And the third part is it forces you to be more like the communication. You're inside a company, like communication skills are way better than non-open source companies because you have to like if you do not communicate with contributors, like it will be a chaos. So that's like culture you're building on top of that. Uh, and the quality of your code is is better, I think, if you build open source. Because if it's not good quality code, no one will contribute
Yeah.
there.
Yeah.
So yeah, you have to like you are forced to have like good quality code there. So that there are a
Yeah.
bunch of pros being open source. But I'm guessing there are a bunch of cons as well, but I cannot think of one.
Okay, got it.
The
That was
secrecy, the secrecy would be the secrecy would be the con. Like if you are building something secret, which is very rare. Nobody cares about your secrets.
yeah.
Yeah.
Okay, very cool. Talking to you about this open source stuff. So now let me switch our conversation to more academic rails, and let's talk about you as a dean of computer science school, right? Am I right?
Okay. Yeah.
And can you tell us, I mean, how you ended up at, because when I think of you, I by default think about the dean of the school where I studied. So uh, how you ended up at the University of Tbilisi, and yeah, just tell us a bit about your journey, how you got there, and
Yeah. So it was 2010. The Mathematics and Computer Science School was getting started, and they needed a lecturer for the first course. Basically, there were no students yet, so I I talked. I don't remember me applying. I just talked to Amiran, who back then was dean, um, and just we I got access. So I had a lecture prepared. I delivered the lecture, and then that was it. So I started working and delivered the first software engineering course, which was programming methodologies. And then the second one and the third one, then I got involved a little bit more and started thinking about the curriculum as a whole, and we redid the whole curriculum. After that, of the Mathematics and Computer Science School, the Max school. I taught a bunch of courses there, like probably every other course actually,
yeah,
and I was involved in finding lecturers, which is really hard. And yeah, that was the journey basically.
yeah.
So
Basically, I just wanted to ask, like, what other stuff does dean do other than giving some lectures? And you kind of answered that already, but maybe there are some other things which you daily did or back then or do now, or
main so yeah, the two things are like curricular development, like what courses should we have, what topics should each course have. So that's one thing. And the second thing is finding the teachers, finding lecturers, professors. So this is like two main jobs of the dean, basically. So
yeah.
it's
And
both of them are. So the first one is not hard. The second one is very hard.
yeah,
So yeah.
okay. And not everyone enjoys teaching, and not every other software engineer enjoys the things which you do at the university, I would say. And what is the thing that sticks you around so much? Is it so long? Is it just passion? Is it just something you love about this domain of learning, or what is that actually?
Um, I love teaching, so that's probably the factor. So I love talking to smart people. Um, so that's another one. And I think so. I think I'm helping a little bit. So that's kind of where motivation comes from. Um, and yeah, so myself, I'm an obsessive learner, so I always learn new things, and uh, and I love uh, uh, whatever I learn. I love to contribute to someone
Okay.
basically to teach. That's the contribution you can give. So that's kind of best job I can have, teaching, because I really, so it's not a job. I love doing that.
Yeah.
So that's the best
Yeah.
thing for me.
That's a great answer. Uh, and now I want to ask about there is let's don't like kind of concentrate on the naming, but let's say like software engineering and computer science, or we can rephrase it like some practical business problem engineering and some more kind of scientific part. So what's the difference between them, and is it first let's talk about that, and then I'll follow up with some other questions. So
Well, yeah, that's probably, yeah, that's different. So for me, computer science, I see computer science as in three parts. Like there is a science part where you come up with new things, like you experiment a lot and come up with new algorithms or whatever. So that's kind of I see where like people in white coats and like writing down the equations on the boards. So that's the first part, and it's really really big and very cool part of computer science. The second part is so every computer scientist. So the computer science is an applied field, right? So whatever you come up with, it goes to the end user at the end of the day. So whatever you come up with, you have to be able to implement that. So that implementation part is the software engineering, as I see it. So the first part is the computer science part, the science part in computer science, right? The second part is the engineering part, where you have to build something, whatever you came up with, and the second part is the art part, right? There is a very cool book like science and what art and science of programming, if I remember correctly. So there is an art part in computer science as well, and it's pretty big. So that's how I see computer science. And software engineering is part of it, definitely. So yeah, you cannot be a computer scientist without knowing software engineering. You might not know like all the different software engineering areas, like how to build something on iOS or how to build a web app or whatever, but you have to know the software engineering, like the basics of it, the methodologies and the paradigms of it to be a computer scientist. So that's how I see it. It might not be what it is.
What about the vice versa? Now let's get to my next question. So, do we need a computer science degree? I'm just saying it very roughly, but do we need to get to the university and get some knowledge from computer science stuff to become good software engineers? Is it related in that sense or not?
Yeah, it depends what you want to build, right? If you want to build new like stuff which is on the edge of technologies, like, and you want to build like new stuff, you have to understand whatever this new computer scientist guy came up with, or you build it yourself, like came up with new algorithm that you implement that. So if you want to be on the cutting edge, you definitely want to would know this, like would know the science stuff. But if you are not building on the cutting edge, yeah, you don't need the science. Like you can, I don't know, you can build an mobile app without knowledge of discrete math, for example. So you don't even need like math. Like high school math will be okay to build like maybe 80% of mobile apps, and you can be like but that's kind of so what would be the good example? So for example, I can draw an apple, and everyone can draw an apple, and that's kind of, but some of the drawings are the art. Like for example, Picasso, when draws an apple, it's an art. What you might not understand, it's an apple, but yeah, it's an art, right? But when I draw an apple, it's
just an apple.
Nothing. Yeah, it's the same, like same as Picasso. You don't understand that it's an apple. So and the same goes to the software, right? Some of the software is an art, and if you are building an art, a state of art, software, then you'll have to know the science behind it. So you are an artist. Like every computer scientist is an artist as well, for me. And if you can be just a drawer, like you paint whatever, like you paint this in the yellow, this part in green and whatever, but you are not an artist. But even though you drew an apple, and yeah, very cool apple. And the same thing, you build an app, and very cool app, and you probably got a lot of money on it for it, and you build a business on it, whatever. But it might not be an art. So that's how I see it.
Yeah. So, recently, you mentioned this like three parts of computer science, and one of them was art. And now you kind of told a bit more about this art part of computer science. But can you tell us a bit more, or give some example? I mean, what kind of software and what kind of people are artists who create this piece of art? I mean, can you tell us this Picassos of software computer science, for example? What's that you mean by behind?
The art part for me is in computer science is the good designs and good engineering in the code, like good code base of a good software, good architecture, and that's the art part. Like you can build any, like same product you can build like 10,000 ways, but like that, not some of them will be art, like with good design, with good architecture, and some of them will be like nothing. So that's for me the art part. I see art in code when I see like even one function, even one method could be a piece of art. How that method is written, and the same method could be like doing the same thing. It could be like nothing. So yeah, that's how I differentiate there.
Yeah, good. And so basically, I was lucky enough to study coding at university, and I always have problems when people approach me and ask how to start software engineering. And I'm very biased, I always say, and I just don't know how you should learn it on your own because I have never done that. And at the university, we had such subject. The first interaction to coding is program methodology. And the one thing which still even now sticks to my head is this concept of decomposition, which is kind of around it is built this whole subject. So that's what it is taught there, basically. And it still remains one of the best knowledge collections of mine from university. And speaking of this art functions and some cool code, can you tell us, like, how does so-called clean or good or artistic code look like to you? Can you tell us some key factors which make bad code, good code, and piece of art?
Oh, that's really, I haven't thought about that actually. So that will be hard to talk about, but I'll try.
Yep.
So yeah, the composition you mentioned, that's kind of thought process, right? Like how I have to solve a problem, and what's the thought process I have to have when I'm trying to solve a problem. And the composition is like creating sub problems of a problem and solving them. Like if I can solve this sub problem, then and this, like then the whole problem will be solved. And each sub problem could be divided up to even more. Like it's stepwise refinement. Also, they call it the decomposition. So that's the thinking of it. But it's not the only one thinking process, right? When you thinking about problem solving, for example, programming, object-oriented programming is one of them as well. Like you can think, like when you're solving the problem, you can think not like as what are the little small problems that I can divide this up with, but you can think about an actors, like an objects. What would be the objects who would, and what roles would that object have, and what methods or what behavior would that objects have, and how would those objects communicate, right? And you will divide this whole problem with like as an object, and then you create a flow like where you how the basically data flows between these objects, and what this one object is responsible for, what the second object is responsible for, whatever. So it's like different thinking process, like totally different thinking process. And you think like oh, if I have objects and they are like communicating with each other, then it's probably best to have as little dependencies between these objects as possible, because like it boils down to the maintainability of the code we talked about earlier, because you want to have changeable, like your code should be easily changeable. And if there are like lots of dependencies, then changes are very hard. You have to, if you change one place, you have to change a bunch of other places where this is dependent, where dependencies bubble up. So yeah, you think, so you think like differently, and this, for example, this object-oriented thinking process is very similar to how CEOs think when they think about the organization of their company. And I think that's why a bunch of software engineers are very good CEOs, because they are problem solvers. Like computer scientists, they are problem solvers first, and CEOs are also mainly problem solvers. But yeah, that's object-oriented programming is not the only. It's like the decomposition and object-oriented programming are not the only ways to think about problems, right? There are like functional or whatever, like lots of paradigms you can approach a problem, and depending on which paradigm you approach, it depends on the problem itself. Like some problems are easier solved with one paradigm, and some problems are easier solved with another. And that identifying that is not easy. That's really hard. That's why you have to know like these these different paradigms. And after that, when you identify, oh yeah, this, because the another thing is like any problem can be solved with any of these paradigms. Like anything can be solved like in any of these paradigms. And so that's also like this where this hard part comes, right? And whenever you determine okay, I'll solve this with decomposition. Okay, then you think what would be the stack, or what would be the programming language you would be using here, which is more closely coupled with this paradigm. Like if you are want to solve this with functional code, you probably would not choose C, even though you can totally write functional code in C, but that will be a miserable experience. So there are lots of thinking going when you're trying to solve a problem. And what it all boils down is the actual code. And when you see the code, you see this whole thinking process. Like you see the result and you see, how this result came by and what was the thinking process behind it. And you then can determine like if it's art or not, right? But I don't know off top of my head. It's probably very subjective.
Yeah.
What is an art, and who are the artists of the computer science world? But that's very subjective. So I see some code as an art and some code as not. But yeah, I'll think about that. Maybe
okay.
Next time when we meet, I'll have better answer here.
Yeah, cool. Now let me. You are one of the best person to ask this question to, so let me ask you this question. So, as I said, I'm biased. I love university stuff, and I really encourage everyone to like go for this deep education path and learn everything slowly and very kind of fundamentally. But I have one big problem in university flow of education, which I personally kind of faced, is that this learning process is super intense. For example, I remember learning some really, really, really cool subjects, kind of on 60% of my abilities, because I maybe didn't invest enough time, but mostly because I had like lots of other stuff to do. And how can we address that kind of problems, like to get as much from university as possible, and like for persons like people like me, because there were some supernatural people at university, which I'm definitely not. But yeah, so how should can we even solve that problem at all, or this is what it is, university? So you learn some things more fundamentally and something like kind of less fundamentally.
Yeah, let's start with even though I'm dean of the university, so university is not for everyone,
Okay.
and that's very important. Like, not everyone would enjoy being at the university, and not everyone will get what university can provide. Like, so basically, I view education as a pyramid, like where on the bottom of the pyramid there is like uh, fundamental stuff like math, like how to add addition, subscribe, how to subscribe, how to multiply, whatever. And out of that, you like add knowledge. And on the top of the pyramid is like very technologies that you use to start working. For example, like, I don't know, iOS programming or like machine learning or whatever. So that's in my view, that's what education is. And how you would approach this, right? So your goal is to learn this like top tier stuff, like this pinnacle of the knowledge, and then you will start working somewhere. Like, if you learn like web programming, you can start working like as a web software engineer somewhere. But so there is two approaches. Like, university, what the university does, the university has a bottom up approach. It starts with the fundamentals and builds up to the top. And for me, this is a very good approach. Even though it takes a lot of time to get to the top, you know how everything works, how you know the whole pyramid, even though you don't know all the top
Yeah.
points of this pyramid, you know everything basically. It was basically, if you got to the like web programming, switching to iOS programming will be very easy, right? You would learn some additional stuff, and you will easily switch this tops, like this heads of the pyramid. So, and for example, if web program is no longer cool, you can start doing AI, right? If AI is no longer cool, you will start doing the biology. I don't know. So
Yeah.
that's very good thing about university. So if you approach the education like this, like going bottom up, then university is the best place to go. But it takes longer because you have to learn a lot of. You think they're unrelated things, but they are really related, and they come up on top. So another approach is to go like from the top and learn iOS, for example. Just start learning with iOS, so you can learn coding iOS really fast. Like, if university takes you 4 years, you can learn coding iOS in a year or so. So you will start working way faster, and then at work you might go down the pyramid and learn fundamentals later. So that's different approach, but it's kind of not structured. You don't know what you don't know. You have some knowledge gaps, and it's really hard to navigate there, like what to learn. And if you don't learn, iOS will not be cool sometime, and you will have to switch to um, another technology, which will be like you'll have to basically start from the scratch, like one more year, and then you will start working. So it's a trade-off. For some people, bottom-up approach is good. For some people, they prefer like starting working and then like going down the rabbit holes and exploring this pyramid. So that's the knowledge people should have when they attend university. And now everything is free, right? So everything you can learn at university, you can learn for free anywhere in the online, right? So every book, every lecture, they everything is online basically, even free or very low cost.
Miserable, yeah.
So yeah, so that's up to the people to decide. One more thing that the university provides you: if you go to the university, try to go to the university where the smartest people go to.
Yeah.
Because your smartest people will be your friends. And your network will be like consist of smart people, and that's very, very important. That's where, and if you don't go to the university, it's not likely you will have as smart network. You will start working somewhere, but yeah. So networking at university, networking and creating lots of friends from different departments or whatever, that's very important at the university. So if you go to the university, definitely make a lot of friends, because that's probably number one plus of the university, which is not on the it's not that, maybe it might not be that clear for the students.
Yeah.
So that's my take on universities vs non-university education.
And maybe I kind of didn't express my question very clearly. Let me rephrase it once again. So basically, what I asked was that as this university process is super intense, there are lots of subjects, lots of exams, homeworks, assignments, lots of things happening there. Sometimes you might not be able to pay that much attention to some subjects as you would. For example, I didn't take distributed systems class at university, but then I followed it on myself via these online lectures, assignments, everything. And that process was super effective for me because I decided to learn it on myself. I learned it when I wanted, and I kind of got a lot from that class, even though I didn't take it at university. So is answer to this to just work harder, or we can kind of approach this problem during university years?
Yeah. So I don't really understand why it's hard to do that on the university. But yeah, so so I don't know the answer to that question, to say the truth. It depends on the person and what person really strives for, or how much time this person has, or whatever. But the problems I see now with the universities is the courses. Like, courses might not be the best way to learn, because so courses are not relevant. So what the course is, right? I'm speaking to 300 people, and like why and like 300 people are at the hall or whatever that called the classroom, and I'm speaking to them, right? And then some of them may ask a question, a lot of them do not, because they are afraid of asking questions. What if they ask stupid question? Even though there are no stupid questions. But yeah, so the thing is, so it's not efficient for all 300 students, right? So for some of those students already know what you're talking about. Some of your students do not understand what you're talking about because they have some knowledge gaps they didn't knew they had. And like for half of the students, maybe your topic you are discussing may be relevant. And you are talking for an hour. So at our university, we have like 1 hour lectures. Some universities have 45 minutes, maybe an hour and a half, but it's a lot of time. And attention span also is not that long for students or for people
Everyone. Yeah.
basically, and it's shrinking now attention span. So you are so when you're talking, like student listens for 5 minutes, and then the attention span goes away, and basically they drop whatever you were talking about, and the new knowledge gap is creating there. Like very good lecturers do repeat themselves every once in a while. Students ask questions, and so they repeat same concept several times because of this. Uh, but it's still there are possibility of knowledge gaps, even though you attended the lectures.
Yeah.
So, and then you have to go back to the textbook and like whatever lecturers said, then you have to read it. And oh, okay, so that what I missed, oh, that's like what lecturer didn't mention because he had no time, whatever. And it's really time consuming. It's really time consuming, and I think yeah, it's not efficient. So when you're doing it alone, like when you how you did the whatever course that was,
Yeah. It
it
was, yeah.
might be little bit effective. Like effectiveness might be like better there. So yeah, that might be the problem.
Yeah. So with all these benefits university brings, there can be some kind of these things which maybe person should be aware of and kind of try to kind of maybe build some framework of his own to deal with such situations, maybe individually or something like that.
Yeah. So yeah, the like learning online with like videos or like learning from the textbooks. So that's very good skill. Like you will. So one thing to understand is when you attend the university, a lot of people might think that, oh, I'll attend the university for like 4 years or for 6 years, or whatever, and I will learn whatever I want, and then I will start working,
Yeah.
and yeah, that's all the learning I needed. But that's not true, right? So if you finish learning, that means that AI will come and say, "Oh, yeah, I know what do you know? I know lot more, and I will replace you for like way less because I'm cheaper." So you have to learn constantly. So the best thing you can learn is how to learn,
Exactly.
because it's the best skill you will have. So in a university, if you learn how to learn, that's like already like you will be well off, right?
Yeah, exactly.
And
That's
you
what I
will
learned
learn
basically. Yeah.
throughout.
That's actually what I
Yeah, so
learned.
that's very
Yeah.
important skill.
So yeah, so I might have missed some classes,
Sure.
some technical knowledge, but the ability that I can learn what I want on my own, that's what I really applaud the university for that. So that's the best takeaway, I would say. Yeah.
Yeah, that's the must, right? Because
Yeah.
the technologies you learned, like in 5 years, they will be
Yeah,
outdated.
obviously. Yeah.
But the fundamentals you learned, they won't be outdated, right? Because
Yeah.
that's why I love university. The fundamentals are always there. Like technologies will change, but
Yeah.
fundamentals are there. So that's always relevant.
Yeah. I'm there as well with you. So, okay, now we talked about uh, lots of things so far, and now let's go to our kind of sweet topic, which I want to talk with you. And like speaking of this learning, we talked a lot about this learning stuff, learning process. We outlined some benefits and problems, etc. And can you now tell us what are you doing right now, and what is this project you're working on? What is the problem? And let's just continue in that way.
Yeah. So currently I'm working on a new startup. It's called Vitsi.ai. And basically what we do is we want to redefine education using an AI tutor, and this pyramid I was mentioning. So
Yeah.
basically, what we so any knowledge you want to learn, any knowledge, if you want to learn, you have to know the prerequisites of this knowledge. And if you know the prerequisites, you can learn this knowledge. And that's how this pyramid comes by, right? So for example, you know how to count to 100 and you know how to add numbers. And then, you can learn how to multiply, like multiplication. Then if you know multiplication, you can learn division. If you know, I don't know. So like that, you can build your knowledge and you can get to the whatever knowledge you want. So, and what we are doing is we are building this map of the world knowledge. And uh, we want to create this like 5 minute topics, like very, very as small as possible, and create this prerequisites for this topic and create this like whole pyramid, basically knowledge of the world. And after that, you'll be able to learn whatever you want, like whatever path you want. You can choose basically whatever goal you want. We will choose the shortest path to that goal, and you will be able to learn whatever you wish. So that's the main goal. And yeah, let's see what will come up.
So just to kind of rephrase it, if I got it correctly. So let's say I want to learn. Okay, let's say I come to Vitsi.ai and I tell Vitsi.ai that I want to write Android mobile app. Okay, that's what my goal is. So basically, what you will do, you will start from the bottom of the pyramid for that specific pyramid, for that knowledge. Let's call it pyramid, and you will kind of guide
Okay.
me from bottom to up with these small chunks of resources and knowledges, and they will kind of add up to this final goal. Is that correct?
Exactly. At first, you will have some quiz so to understand what you know already in that pyramid. So you have some knowledge already, right? And then you can build up to the Android development. So, and the cool thing there is you can clearly view whatever. It's like you know the world knowledge. What is the world knowledge? And you know what you know in this world knowledge. So basically, what the part you already know, and here is this Android development or Android engineering thing I want to learn. And that's the part of the pyramid I have to learn to get there. But there are a bunch of other parts, right? You can explore, like, let's see what's here in biology, right? I don't know what's what the DNA is, but I know all the parameters. But let's learn what the DNA is, and maybe I like that this like biology. Maybe I'll go there. So when we came up with this, so the idea was for the kids to be able to explore this knowledge and explore the way, like it's kind of game, right? You are opening up new levels, like you learned this and now new levels are open up, and okay, I learned like multiplication, or now I can learn whatever division and whatever. And you can explore in the direction you love most. You can learn the I don't know, DNA here and multiplication here, and if you love the biology, you will explore biology more. So that's what I don't like about the education system now, like in schools especially. Like everyone is learning the same thing. Like it's kind of very outdated for me. But in this way, you could expand your knowledge in the direction that kids could expand their knowledge in the direction they love. And it's for like lifelong learning. So currently I'm also like I'm learning every day. So I would love to have this kind of tool to explore different areas I can learn and explore deeper the part I will be interested in. So that's the approach we're taking.
Yeah, actually, like you just mentioned, this you're obviously an active learner. You just mentioned that you like constantly learn new stuff. But what is your approach now? Let's say what if I tell you that you should learn aerospace engineering, let's say, some very random field. What steps will you take to do that right now?
Yeah, that's a very good question. So what I would do is I would create this graph first,
Yeah.
what I know and what I have to learn to get there. So that's how my brain is wired already. So that's the product I'm creating.
Yeah.
It's really similar. So yeah, so I will create this graph, what I have to learn to get to the aerospace engineering. It will be like just like physics, whatever. And then I will search for books and courses that are relevant to that concrete field. But that's very hard because books use so like my experience in that. So I have like experience in that exactly. So I wanted like whatever 5 years ago, whatever. 5 years, maybe not five, 3 years ago, I started exploring um, biology, and I wanted to learn biology, and I still am exploring biology, like when I have free time and learning new things there. And okay, I started with like exactly like this. So I wanted to understand bioengineering and like creating the medicine for different diseases and how this works and what I have to learn to be able to do stuff like that. And I started with the so so the best way you can do this is to go to some university and learn what they teach their students who become that. And yeah, I did that. I went to MIT, I think, and started learn. So I draw the map, whatever their subjects are, whatever the topics are, and I started learning and took the first introductory course in biology and got a very cool book. And I started reading the book, but I understand nothing from that. It was very hard. Oh, then I thought, okay, I don't understand that because I don't have some prerequisites. So I went back to the school books like seventh grade or whatever, and started from that. But it was very, very not efficient because they were in this school, like seventh grade school, they were talking about like very primitive things, and there were and I couldn't find good book actually for seventh grade. I tried a bunch of online courses as well. I tried lots of things, and it took a lot of time to understand like first chapter of this book in the from the this MIT, and then the rest was easier when I understood the first chapter. But understanding the first chapter took probably, I don't know, half a year, maybe more.
So
So that process was really frustrating. I wanted to quit like 10 times, maybe more, because I don't understand. Couldn't understand what I was reading.
so
And it
basically
was
like
like
yeah.
Googling, then,
Yeah.
yeah.
Yeah, so like one problem which is kind of very obvious here is that this organizational stuff, right? That you just don't know what resources to take, like after what and things like that. So the first thing you do, you kind of structure this stuff in a very well kind of tree or map or graph or whatever, some list of resources or prerequisite stuff, right? But what about like the actual resources? I mean, uh, I'm pretty sure that there are some topics where there are no such good resources out there, and maybe you should take care of resource creation as well. And how big of a challenge will that be for you? I mean, you can't create biology resources, right? Obviously, on your own. So, how do you envision that process?
Yeah, but so yeah, of course, like I cannot create resources for the world knowledge. So how we envision that is we will have content creators who will create the resources for us, and we will pay them
Yeah.
as per how, like there are different ways how you could pay them in front, all at once. You can pay them per usage, like every view of their video, whatever. So that's how we want to approach this. And also there are lots of resources online already created, so you can parse them and create the graph out of them, create this pyramid out of them. That's also the part of this project, and that's like AI part actually, and very cool.
So yeah, that's
But yeah, but still, the content creation will be the part of this with CAI anyway. I'm as well creating content for software engineering and probably math. I will create some content for math as well. But other than that, the content will be created by experts in those fields.
yeah. And like, what is the state for now? I mean, I will definitely link in the description Vitsi.ai, like the website. And what can people get right now when they enter this website? Is there some content already ready, or it's kind of in development phase still?
Currently, content is in development phase, so we do not have a content.
Yeah. And what
So
is this first
it's
niche
not that.
content which will be available, like the first segment of knowledge learning?
Oh yeah, that we are actually experimenting on that. So we started with the software engineering content, which but it's really hard to differentiate between. But there are lots of resources online, and it's really hard to differentiate between yourself and, even though it's kind of new approach and like whatever, it's hard for differentiation, because there are lots of free resources. There are lots of Coursera's or Udemy's or whatever courses online, which and if people want to learn software engineering, they tend to go that way. And we are right now experimenting on what vertical is the best to approach. Um, and the another thing, the hard thing in software engineering part is it's hard because you'll have to have a lot of software on top of the, like, you have to have content, but you'll have to have the ability for users to write software on your system, and that's the hard part. Basically, you'll have to recreate whatever Ripple does right now. But yeah, so we are thinking about different verticals and experimenting with the users, what vertical would stick, and after that we will create the content on that. Meanwhile, we are parsing the free content and creating this like free content for everyone that could be digested for everyone. Like, we are creating this graph on free content, and there are a bunch of topics on that already. And so, but right now it's not ready for user
Yeah,
consumption, but it
got
could
it.
be like in several weeks.
Great. I guess that was it. So thank you very much for spending your time, obviously, this evening. And it was just an amazing for me to talk to you about all these various topics. So thank you once again. And obviously wish you all the best and all the luck in this new endeavor. And hope VCAI will kind of
Thanks, Echo.
get up soon. So
Thank you. Thank you. See ya later.
see ya.